8 minutes ago, a stream of light left the surface of the sun and began crossing the emptiness of space. Right now, it is hitting your eyes, warming your skin, and lighting the world around you. But what you are seeing is not the sun as it is in this exact moment. It is a snapshot from the recent past, and the deeper story behind that light is far more dramatic than most people ever imagine. Beneath that steady glow is a restless, violent, constantly shifting world of storms, eruptions, and rivers of superheated plasma. Today I want to take you on a journey through that star, layer by layer, to show you what is really happening there and why it matters more than you might think. I've spent years breaking down complex space science into stories that feel real and understandable. And once you see the sun this way, you will never look at daylight quite the same again. Most of us grow up thinking of the sun as a calm, bright circle that rises and sets with predictable rhythm. It feels stable, dependable, almost unchanging, but that is an illusion created by distance. The truth is that the sun is one of the most dynamic places in our cosmic neighborhood, and its activity can influence everything from satellite signals to the shimmering curtains of light that sometimes appear near the poles. Understanding what happens there is not just fascinating, it helps us understand our place in a much bigger system. Let us start at the very outer edge, in the faint halo that stretches far into space. This region is incredibly hot, far hotter than the surface below, which seems completely backwards at first. Here, glowing streams and arcs of plasma are shaped by powerful magnetic forces, forming structures that can extend for millions of kilometers. Normally, this outer atmosphere is hidden by the brightness beneath it, but during rare moments when the moon blocks the central glare, a delicate crown of light becomes visible, revealing just how complex this region really is. Scientists study this area using special instruments that detect forms of light our eyes cannot see, because those wavelengths reveal temperatures and motions that would otherwise stay invisible. When you look at images captured this way, those darker areas act like open highways, allowing charged particles to stream outward into space. When those streams reach Earth, they can interact with our magnetic field and create glowing waves of color in the night sky, reminding us that events on the sun can paint the skies of our planet. Moving inward, the environment becomes even more intense. Here, enormous bursts of energy can erupt when magnetic fields twist, stretch, and suddenly snap into new shapes. These explosions release huge amounts of radiation in moments, sending energy rushing outward. Watching these events is both beautiful and slightly unsettling, because they remind us how powerful natural forces can be. There are also massive loops of glowing material that rise high above the surface, curving gracefully before slowly collapsing back down. Some of these loops are stable for weeks, suspended by invisible magnetic tension, while others appear and vanish in a matter of hours. Imagine arcs so large that our entire planet would look like a tiny dot beside them. Sometimes material that has been lifted high begins to cool and fall back, creating a kind of glowing rain. Even though the word rain sounds gentle, the temperatures involved are still extreme beyond comprehension. Not all material returns quietly though. Occasionally a massive cloud of plasma expands outward and then suddenly breaks free, launching billions of tons of charged particles into space. When these eruptions are directed toward Earth, they can disturb satellites and power systems, which is why scientists watch solar activity so closely. Activity like this rises and falls over a cycle that lasts roughly a decade, meaning some years are calm, while others are filled with frequent eruptions and shifting magnetic storms. One of the most fascinating things about studying the sun is how different it looks depending on the type of light you use to observe it. In one wavelength, a region might appear calm, while in another it glows with intense activity. It is like looking at the same city during the day and at night and realizing how much changes depending on your perspective. As we continue inward, we reach a thin region where temperatures rise incredibly fast, over a very short distance. This sudden jump in heat is one of the puzzles scientists are still trying to fully understand. Beneath this lies a thicker layer filled with narrow jets of plasma that shoot upward at astonishing speeds before fading away. These jets appear and disappear within minutes, swaying and flickering like tall grass in a strong wind. For a long time, researchers struggled to explain how material could move like this in such a strongly magnetized environment. But improved models eventually showed that interactions between different types of particles could provide the extra push needed. It is a perfect example of how science evolves, with new details turning confusion into clarity. Eventually, we arrive at what most people think of as the surface, even though it is not solid at all. From far away, it looks smooth and uniform, but up close it is a constantly shifting pattern of bright cells separated by darker borders. Each cell is a pocket of hot material rising from below, spreading outward, cooling slightly, and then sinking again in a continuous cycle. The scale is enormous, yet the pattern changes within minutes, showing that even the most familiar features are in constant motion. Darker patches sometimes appear where magnetic forces trap heat beneath the surface, making those areas cooler than their surroundings. These spots are often linked to regions where energetic eruptions originate, revealing a connection between what we see and the powerful forces underneath. To make this feel more real, imagine a scientist sitting in a control room late at night, watching live data streams from solar observatories. Suddenly, the monitors show a spike in activity, a bright flare expanding across the surface. The room becomes quiet as the team tracks the event, knowing that depending on its direction it could create stunning auroras or temporary disruptions in communication systems. Moments like that capture the balance between beauty and power that defines our relationship with this star. Looking closely at the visible layer also reveals a grainy texture that might seem like camera noise, but it is actually the pattern of convection cells themselves, the visible signature of energy moving upward from the interior. Despite all our technology, this is as deep as direct observation can go. Beneath lies a vast interior that scientists study using indirect methods, piecing together clues to understand how energy is produced and transported outward. The fact that so much remains hidden reminds us that even the most familiar object in our sky still holds mysteries. Let me share another simple story. A group of students once tracked solar activity as part of a class project, checking updates every day. At first it felt abstract, just numbers and images. But as they began to see patterns and learned how those changes could influence space, whether the sun stopped feeling distant, it became something alive and dynamic, something worth paying attention to. That sense of curiosity is exactly what drives discovery. So, what can you take away from this? Start by remembering that the sunlight you see every day is part of a much larger story of energy, traveling across space. Pay attention to images captured in different wavelengths and notice how dramatically the same star can change, depending on how you look at it. And most importantly, stay curious, because curiosity is what turns ordinary observations into deeper understanding. As we step back from this journey, it becomes clear that the sun is not just a bright disk in the sky. It is a constantly changing world of storms, loops, jets, and flowing plasma, all driven by powerful magnetic forces, from the faint outer halo to the shifting surface below. Every layer tells part of a story about motion and energy on a scale that is hard to truly grasp. Even though we have learned so much, there is still more waiting to be discovered, and future generations will likely uncover details we cannot yet imagine. If today made you see the sun in a new way, then the journey was worth it. Thank you for spending this time exploring with me. If you enjoyed this and want to keep learning about the universe and the forces shaping it, make sure you subscribe, share your thoughts, and continue the journey with the next video.